example for class image classification, where we are following the one. Here in this tutorial, you can easily learn how image classification support for recognizing images. So here, generally, this image classification is helpful to predict the images and also later categorize and move to the predefined categories. May rows. If you take the consider the flowers as example, it may rose or sunflower, anything here. So for this one, we are going to use the text TensorFlow also. So we are going to write a code simply. First of all, we are going to insert the packages where for matplot, and from TensorFlow we can use the import keras also, and layers and sequence, and we are going to download the data set where we have a data set contains generally 5 subcategories, that is like flower, photos, daisy, roses, sunflower, and tuples like that. Then you can use the path where you are writing the code data path URL is equal to HTTP storage at Google and so on, and this helps to download the data from the internet and also from the TensorFlow also. So once you download it, what you can get means we can check the count of the data set images. So for this one, we get the code called image count is equal to lens list data underscore there dot globe and so on. So once you exit the code, it displays the number of images, that is 3617. So you want randomly print some roses, you can write the code by Python, that is roses equal to list data dot dir globe roses, and also you can use the another code called pa dot image dot opener str roses 0. So once give this, like it will take the image from the data set and show the visualized image also. A simple example here, like this, and some more tuples also. So if you want to load the data from keras, we can use the code where you can access all the things, and before that you can create data set. So if you want to create data set, we have to set some parameters also, like we can give batch size equal to 12, followed by image height 100, and followed by image is equal to 180, like that. And also you can train. So training, testing, validating is very important, and later you can go ahead with and move for the graphs also. So you can write, that is train data followed by validation and seeds image size, and next code you can write validation underscore ds equal to tf dot keras dot utilize dot image data set, and where it will give the information like how many images found belong to the given 5 classes, and also how we are going to take here. Apart from this, we are going to take 733 files for validation here. Then we can write the class names where you can write categories like letter, daisy, roses, sunflowers, and tulips, like that. And now next code segment is visualize data. So if you want to visualize, you can write the code called import matplot plot as plt. Then you can use the simple code and plt dot title and plt dot stuff, like that. Once given the code and execute, it display the images randomly, like roses, tuples, and sunflowers, and again some roses and tuples to here. And also you can use keras model.fit where help to train easily here. And then you can continue code and configure the code, then standardize the data. So if you want to go for standardization, you can use normalize dot underscore layers equal to layers dot rescaling of 1 dot by 255, like that. So there are many ways is that you can use the layers also, then following the code. So this today we see the basics only. Then you can approach keras model here. So with the help of this one, we can create a model. So if you want to create a model, what you can do, you can generally write the code. Before that, here now the keras sequential consists of 3 convolutional blocks only. One is called convolution and end with the convolution 2D, another end with max pooling 2D, and also another one is a dense, like that, and real also. Since if you know deep learning basics, you know the meaning easily here. Understand. Then you can define the classes, that is number underscore len class underscore names, and followed by the layers, then you can execute the code. Then compilation is very easy. If you want to compile, you can write code called model dot compile of automate Adam and continue the code and matrix equal to accuracy here. Then summary. So if you want to display summary, what you can do, you can write the simple code in Python, that is, or Google Colab model dot summary. Then you give the information of max pooling, rescaling, and dense plot, flatten, and max pooling also. Then how to train? If you want to train the model, you can write the set the approaches, that is approach code 10 initializing, then history is code model fit, and continue the code. Then it takes definitely some time. After executing the approach successfully, we can go to the view the result, that is visualize the training result. So if you want to visualize the training result, you can write the code called accuracy, a function called accuracy code history of accuracy, and you can write the plot curve, that is figure subplot followed by the everything like metrics like training loss and variance loss, and generate the code. After executing, clearly it visualize the training and validation accuracy, and similarly another graph showing also training with validation loss here. This showing the accuracy, this showing the validation loss. So since this is the graph, here we have very good result, that is the training and validation accuracy is more, and another one is less. Here also, here validation loss is very less, because loss should be very less, then only you can identify this is good like that. Then overfitting, there will be some overfit there, you can avoid it, and data accommodation is to maximize the data, and also you can apply data accommodation, and then you can write the code for visualize some data accommodation. So if you give data accommodation, there will be images there, sample images, suppose 5 images there, you can make it a 15 also. That is possible with the help of data accommodation here. So we are going to use the accommodate examples where write the code and display. It will maximize. So yeah, it will augment the images and display multiple times like that. Then dropout if you want to use. Then again set the sequential convolution layer and compile and train the model. Then you can use can build and check the model summary where is giving all the clear information about the parameters, output shapes, and etc. Then here there will be a training parameter showing here and non-training parameters here. And also we are going to increase the approach value, that is 15, before given 10 only. So then you can write the code as usual, that is history is code model.fit. Then you can execute, it takes some time. Then we can easily view the training result, that is visualize the training result easily. So we are writing the code, you can see the graph where you can see the validation accuracy as well as the validation loss here. So we can how our model is good based on the prediction new data only. If you have any new data, we can predict based on the new data also. So you can apply the code where from internet you can take and download the new data set. You can use the tensor light and then convert the model where you can use the converter and save the model easily. Then run the TensorFlow line model, and at the end you can go for prediction also. So like that you can classify, then you can go for print the result and so on. So like that you can give, at last you give some valid information. So this is a way how we can perform image classification using the TensorFlow and also executing the Google Run with the help of Python coding here. Where major thing is you can use the data accommodation. Thank you for watching the video. Thank you.